All right. Now we're given some functions and their formulas, and we want to determine whether they're even or odd or neither. So just remember what we found before. I'll just write it up here at the top. Let me see if I can scroll. Whoops, scroll up to there. Let's see. All right. So what we found before is that a function is even if if f of negative x equals f of x, right? So we reflect it across the y-axis and it's the same function, right? An odd function, the reflection across the y-axis is equal to the reflection across the x-axis, so negative f of x. All right, that's just the definition of even and odd functions. So all we really need to do is look at f of negative x and and see what happens. So f of negative x in this first case, right, if we just replace x with negative x, we get 1 over negative x, which is the same as negative 1 over x, which is the negative f of x. All right, so f of negative x is equal to negative f of x, right? The reflection across the y-axis is equal to the reflection across the x-axis. So this is an odd function. Odd, whoops, odd. That's an odd function. All right, so all we're going to do is plug in negative x and see what happens, right? So we're going to put negative x into this function and take it to the fourth power and subtract 5 from it. So remember that negative x to the fourth power means negative x times negative x times negative x times negative x, right? An even number of times we're going to end up with a positive. So this is x to the fourth minus 5, which is the same as h of x. All right, so now the reflection across the y-axis is equal to the function, the original function, so this is an even function. All righty, again, going to look at p of r here, but we're just going to substitute negative r in for r. So we get 1 over negative r, that whole quantity squared, right, which is just 1 over r squared, and that is the same as p of r. Okay, so when the reflection across the y-axis is the same as the original function, that means it's even. So that's what we've got here. P of negative r is the reflection across the y-axis. So this is an even function. All right, so finally, let's do q of t. So all we're going to do is look at q of negative t. And substitute negative t in for t, cube it, and negative t squared. All right, let's simplify that. Now when we have an odd power of negative t, it's negative t times negative t times negative t. All right, so we have the negative times negative is positive, but when we're taking it times the negative again. So this is negative t cubed. All right. But when we square negative t, take the negative times the negative, we get a positive. So then, but there's a minus on the outside of that. So this is minus t squared. All right, a lot of negatives to take care of, to keep track of. But just remember that even powers of a negative are positive. Odd powers of a negative are negative. All right. Now, we want to compare that. Is that equal to q of t? Is that equal to q of t? No, that's not equal to q of t. So let's look at what negative q of t would look like. If we just multiply all of this function by a -1 and distribute the -1, then we would end up with negative t cubed plus t squared. So is this equal to negative q of t? Nope, it doesn't match, right? That our t squared in our t squared is negative in the q of negative t. And so that's not equal to negative q of t either. So this one is neither, right? It doesn't match either q of t or negative q of t. So this is not even or odd. All right, that's all I got for this section. And I'll meet you in class.